Hello everyone. Today we are continuing talking about Markov chain approach to solving probability questions. And the questions that we are addressing today is the following. We keep flipping a coin until tail head head or tail tail head occurs. Now what we are interested to know is the probability that you get tail tail head before tail head head. And remember, before we discussed that there are two main types of problem. One is time till absorption, and the other type is probability that the particular state will absorb the event and will end up in that particular state. So um, let's tackle it in the following manner. First, we will look at the table provided by the book written by Mr. Zhu. It's a practical guide to quant finance interviews. Another name is Green Book. And this Green Book offers the following game. This is quite interesting game. One can play with friends. You keep flipping a coin infinitely until player 1 or player 2 wins. Now, the game is in general about 3 consecutive coin tosses. If there are 3, it means there are 8 possible outcomes. So if player 1 chooses one of these 8 outcomes, what should player 2 choose to have odds being in favor of player 2? Well, it turns out, if you do the math, that each time player 2 can have probability which is greater than 1/2. And you can see it ranges from 2 over 3, which is about 66.7%, up to 7 over 8, which is pretty close to 1. Difference is 1 over 8. So let's see what are great combinations to win this game. Well, if you are player 1 and you choose HHH, what should I choose? Well, if I choose THH, I will win with the following probability. Why is that? Well, if you choose HHH, you see all 3 letters are the same. In the 3 consecutive coin tosses, it will occur only with probability 1 over 8. However, for player 2 sequence, which starts with T, gonna dominate this game. Why is that? Well, if there is a tail on a coin, it means no way your sequence of HHH will win. However, all coin tosses after the tail will count towards my winning and would never count towards the winning of the player 1. So if player 1 wins with probability 1 over 8, I will wins 1 minus that, which is 7 over 8. Now let's look at another case. Say you pick HHT, what should I pick? Here there is a trick. You pick your last 2 letters to be the first 2 letters of the player 1. So if player 1 picks this one, I know I should pick something and then HH. So what can that be? It can be HHH or THH. These 2. But you see, HHH is not really a game changer. It's just difference in terms of the last coin, and since last coin with probability 1/2 can be tail or head, you can see that odds are 1 over 2. However, THH, it does a trick, it wins with the probability higher than 1/2, and if you do the math, it's 3 over 4. So you should pick this one. Now, what about HTH? Well, if you choose HTH, what I should choose is something HT. It can be HT. It can be HHT or it can be THT. And you see that indeed HHT has probability 2 over 3. Now going to this case, um, again probability is 2 over 3, and the trick works here as well. We pick something th, so it can be h, th, or t, th. Now it turns out that for h-th probability is 1/2, but for t-th is 2 over 3, which means um, the trick does work, and what we will do with equation for absorption probability, we will repeat the mass and derive this probability. And maybe to mention why TTH is better than HTH. Well, this one having the first two tails. If I get a third tail, I'm not yet winning, but I'm not losing because I'm back to TT state, having two tails. However, if I have two tails, there is no way this player 1 is winning. It's just, for him, it's just the first tail that is matching. So this one is better, and HTH is not as good as TTH. Now, let's start with the Markov chain, what are the states, and then use finally equations for absorption probability. So this is our starting state. Now from this starting state we will go to tail, or we will go back to H, to state S if we get H. And remember, we are interested in, let's denote it like this, we are interested in TTH beats THH. This is what we are interested in. And you remember it was 2 or 3. And what we are going to do is to check it. Okay, so we are either back to state S if we get head, or we continue forward to state T if we get a tail. Now from this we go either to TH if we get a head, or we go to TT. Now TH, what if we get a head? Well, if we get a head, it's over, we are done. If we get a tail, we are back here because there is no any other HT combination of interest, so we are back here. Now TT is more interesting. If we get here a head, then we are done. If we got the tail, we are actually coming back because it's just sort of two consecutive tails. That's it. This is the whole Markov chain for the following problem. We have initial state, we move then to state T if we get a tail, then either TH or TT. TT can go back to TT or to go to the target combination, and TH can go to non-target unfortunate combination or back to T, and we keep moving. And what I mean here with this X and tick mark of victory sign is that we wanna get TTH before, which means beats THH. So what is the probability that this is going to happen? Well, let's first remind ourselves what are the equations. So the probability for absorbing state, target state, should be equal to 1, because this is where we wanna go, and we wanna go there with probability 100. Now, what is the probability for absorbing non-target states? What should we set it to? Well, we don't want to go there, so we set it to 0. Finally, what about transient state? And remember, transient are states which are not absorbing. And absorbing means once you get there, you never leave. Well, for transient state I, it will be a summation over state j's, and this is a probability weighted summation with probability going from state I to state j. So here is what we already discussed before, but it's good to have a quick refresh. Okay, now let's go to mass. So we start with the following: A T H H equals to 0, right? We don't want to go here. A T T H equals to 1. This is where we want to go. Now, what about A T H? This state. You see this state can go back to T or go to the absorbing non-target state. So using this formula for state TH, which is transient state, we say that this probability 1/2, it goes to AT. So if this is state I, it can go to state J here, which is still state J here, which is THH. And it goes to this state as probability 1/2. Or it can go with probability 1/2 to A THH, which is happen to be 0. Now, next state, let's do, for example, TT. Well, TT goes back with probability 1/2 to TT, or with probability 1/2, it goes to the target state, which has a probability 1. Now, what about AT? Well, AT can go to TH or to TT. So 1/2 ATT plus 1/2 ATH. Finally, what about AS? Well, from AS we can go back to AS or proceed to AT. So 1/2 AS or 1/2 AT. Now, what can we deduce from the following? Well, from the following we can deduce that AS equals to, just cancel 1/2, kill this term here and cancel 1/2 here. We have 1/2 AS equals 1/2 AT, so AS equals to AT. Alright, now this means that we need to bring this equation here, right? Because if AS equals to AT, we need to start working with AT. This is what we are doing. We say that we have 1/2, now ATT. What is ATT? Let's see what is ATT. We cancel 1/2 here and 1/2 here. We have 1/2 ATT equals to 1/2, which means ATT equals to 1. And here, for completeness, let's write ATH equals to AT over 2. Let's plug it back to our main equation. So 1/2 ATT, which means 1, plus 1/2 ATH, which is AT over 2. Okay. So this is our equation that will give us an answer. What do we have here? We have that AT over 2 equals to AT. Now notice 1/2 over 1/2, which is 1/4. So here what we have is 3/4 equals to 1, 2. With that, AT equals to 4/3 times 1/2, which is 2/3. And here it is. We derived our final answer. The probability AS, which happens to equal to AT, is 2/3. And this is exactly what we had before. Now, a quick recap. How have we done it? So we transformed our probability, our problem at hand, given in a text format, into a Markov chain, where we had starting state, proceeding further, tail Higgs, tail head, or tail head. If we are going to non-target absorbing state, or tail and finally tail head if we are going to target absorbing state. Then we used equations for absorption probability, where target absorbing state probability was set to 1. All non-target absorbing states probabilities we set to 0. We happen to have only one, but we may have several. And then for all transient states, it's a weighted sum over all the states that can be reached from this particular state, weighted by the probability going from this particular state to the corresponding states that can be reached. And that's what we've done. We went through all the states, we found that AS equals to AT, we plugged numbers for AT and found what AT equals to. And you see AT is 2/3, which is about 66–67%. And this is the answer. If you're playing a game where first player picked THH combination and you're picking some other combination to beat him, this is a combination that will do the job. It's tail head, and the corresponding probability to win is 2/3, which is bigger than 1/2, so you have odds slightly in favor of your combination. Alright, that's how you do it. In a series of short 3 videos, we started with what is a Markov chain, that we talked about approach for time till absorption, and finally today we talked about equations for absorption probability and found what is the probability to get to a particular state. Thanks for watching, stay hungry, stay humble, till next time.